our first speaker this morning is going to cover accessibility guidelines, pedestrian facilities, ADA requirements. And this is Bill Campbell with the MDOT Design Standards Unit here in Lansing. And so he's in charge of interpreting all these ADA requirements for public rights of way, particularly because that's what MDOT covers, obviously, is public right of way. And working with the actual standards that are listed in the standard plans, as well as interpretation and assistance and training like he's doing today to help folks properly build your ADA ramps and accessible pedestrian facilities. So first off, Bill, should be good to go.
All right, well, thanks. Good morning, everybody. Today, Steve pretty much covered everything, but yeah, we're gonna go over accessibility design for permanent construction, basically addressing the ADA ramps in the public rights of way. So we'll just kick it off with oh, there it goes. All right, we have a disclaimer here. Give you a second to read it. But basically, everything you're going to hear from this point forward is for training purposes only and for information purposes only. But we're here to help you guys strive for, to meet ADA compliance to the extent practicable as possible. So, all right. All right, in 2010, they got the 2010 ADAG, and that's basically put together for the buildings and facilities. The draft PROAG, it's still a draft. They keep saying it's going to be approved any minute, but currently it's still a draft. And that deals with the public rights of way. And that's what we're going to go over in class today, is the draft PROAG. So when do you need to upgrade the ramps? So new road construction is what exactly what that says, brand new road. So if we're going to build a brand new road through like a cornfield or a forest or something that has never existed before, it's a brand new road system, full compliance is going to be required. Okay. Most of the times we're not building a lot of new roads, so a lot of the things we're going to deal with today in this class is the road alterations. And if you do a road alteration, you're going to have to upgrade the curb ramps. That's required. Road maintenance, the upgrade is going to be optional. You may or may not need to upgrade the curb ramps and road maintenance. So in 2013, the Department of Justice and the FHWA Joint Technical Advisory Committee got together and they put together these lists of what triggers an alteration and what triggers a maintenance. So if you have microsurfacing, double chip seal, overlaying, resurfacing, those are all alterations. Fog seals, slurry seals, joint repairs, retrofits, things like that. Those are just considered maintenance treatments. However, it's still a maintenance treatment unless two or more treatments contain aggregate or filler. So if you have a chip seal and a slurry seal or a double chip seal, now it triggers an alteration and you have to upgrade the curb ramps. If you just have a chip seal, a fog seal, or a flood coat or something like that, then that would still be considered a maintenance treatment. But just because it's maintenance and it's optional, it doesn't necessarily mean you shouldn't upgrade the curb ramps. You want to look at the condition of them. Are they really bad shape? Look at the areas, or a nursing home or schools or churches or a lot of walkable community in that area. When you do a maintenance job, you may want to just address the curb ramps as well. So the maintenance is optional. Okay, ramps to nowhere. So we've all seen this, right? People putting ramps for no reason whatsoever. But you have to look at, are there pedestrian signals there? If there are, you at least have to provide access to the crossing and to the pedestrian activated signal. Is there any evidence of travel? If there isn't, if there's a worn path, then you have to at least provide a curb cut. You at least have to provide access to that same worn path. If there's nothing there, it's just like grass and looks like there's no evidence of travel, no ped signals, or no pet activated signals, just absolutely nothing there, then no treatment would be required. All right. So where are you gonna start? Well, you gotta know all the pieces and parts of the thing, right? Start off with the curb ramp opening. That's where the curb ramp's gonna go out into the street. Your ramp runs. Your landings, where all of your landings gonna go. Your side flares, your roll curb, or even some infield curb there, if you need it. But transitions back to the existing sidewalk. So you'll need something to transition from the compliant, probably curb ramp back to the existing sidewalks. A lot of times they're not compliant sidewalks, so you'll have to warp that transition slab to match up to the existing. And then, of course, the detectable warning surface, So those are all the parts of the curb ramp design and layout. Site investigation. So a survey is really important. You need to get a good, accurate survey. They're critical for the design and layout of these things. I mean, a little bit off here and there, or they tweak it in the field here and there a little bit. It's like a domino effect, and it can throw off the whole thing. So you want to try to get good design, good survey to lay out these things. Site assessment. Go out and visit the site, look at it. Look for obstacles and problems that may not show up on the plans. Look at the surrounding areas, what's going on, like I mentioned, nursing homes and schools and things. Go out and visit the site. Ramp alignment, you want to use the ramp. You want to use the ramp alignment to line up origin and destinations. You don't want to use the detectable warning services. Don't misdirect with the ramp alignment. Like I say, visit the site. Go out there when it's raining, when it's snowing. Like fall, when the leaves are coming down. We're flattening all this stuff out. Things settle where it's flat and things. So see if the water's ponding. Where's the water going to go if it is ponding? Try to visit the site and assess these things. Look for obstructions like this catch basin here. That's right in the pedestrian access route. So take a look for things like this. And if it does have a catch basin, does it have a accessible grade on it? Does it, an accessible grade has to have a 1/2 inch opening perpendicular 90 degrees to the path of travel. So we want to make sure it's oriented correctly. And again, these things with the small openings like this, these can be a maintenance nightmare, right? I mean, they catch leaves and trash and all kinds of things and plug them up. And maybe you go out there when it's raining and it's ponding, but they got one of these, just needs to be cleaned out, So you want to visit the site, check it out, look for these things. Underground vaults are an obstruction, especially if you're not doing underground utility work, things like that. They can kind of get in the way of how to lay out these ramps. Mailboxes and planter boxes, they just put things in the way sometimes without thinking ahead. So that's why it's always a good idea to go out and visit the site, get a good, accurate survey so you can lay them out correctly. Okay, so when you lay these things out and you're doing design, these are some things you want to consider in the design. Obviously, the survey, like we talked about, how important that is. A site assessment, like I just went over, visit it. Ramp alignment, the detectable warning surface, about not misdirecting and things, and where you have to consider where that's going to be. The type of ramp you're going to put in there. Is it going to be a directional or a depressed corner or whatever? Where the level landings are going to go, and obviously the grade breaks. So these are things that you have to consider when you're designing curb ramps. Okay, so I'm going to go over a few slopes and runs and cross slopes and things like that here in the next few slides. And I just want you to get in your head that there's no construction tolerance on the maximums or minimums on these things. So you want to allow for construction, or finishing inconsistencies. So for example, we have an 8.33 maximum running slope. That is the absolute maximum running slope. Anything above that is non-compliant. Actually, anything above that, they run the risk of flipping over backwards. They have a lot harder time getting up the ramp. So you want to design for something less than 8.33%. So as you're designing it, you want to, 7 or 6 or something like that. And then when they build it in the field, if it does go up, so let's say you design at 7.5 and in the field it ends up at 8, well, it's still compliant, but you allowed for some finishing inconsistencies that were laid out in the field. So you want to try to give them some wiggle room. If you design at 8.33%, boy, they're really, got their feet to the fire there. Same thing with the 5% maximum counter slope. That's the maximum counter slope for between the road and the ramp. If it gets worse than 5%, they can get their caster stuck at the bottom. They could tip over. They could get their foot rest. They get hit the bottom and get stuck there. So again, you want to design for something less than 5%. You want to shoot for something flatter, 2, 4, 3, anything less than 5. And then it allows, if there's anything different in the field after it's laid out and built, it allows for those finishing inconsistencies again. Same thing with the 2% maximum cross slope of the ramp and sidewalks. That's the maximum is the 2% cross slope. So you want to try to design for something less than that, 1, 1.5, try to flatten it out. Do anything steeper than 2%, they got to work really hard on the one side to just try to keep their chair going straight down the sidewalk. And of course, with the snow and ice that we get here in Michigan, if it's steeper than 2%, if they stop or something, they could just slide right off and just get stuck in the grass and on the side. So you want to try to design for something less than the 2%. And then, it gives them some wiggle room out in the field when they actually build it. But anything more than 2% would be non-compliant. Okay. The minimum ramp width is 5 feet. We try to build everything here 5 feet in Michigan. It can be reduced to 4 feet if 5 feet is not practicable. 4 foot is allowed by the PROAG, the draft PROAG. But we try to build it at 5 if it's at all possible. Same thing with the landing. The landing is 5 by 5 with a 2% cross slope in both directions. Again, it can be reduced to a 4 by 4. But again, keep in mind that that's the 2% cross slope in both directions for a landing. That's the absolute maximum. So if you can make a landing 1.5 or 1% or something less than 2%, always try to do that. But a 4 by 4 landing is also acceptable if 5 foot's not practicable. All right, detectable warnings, why do we need them? Well, it advises a change from pedestrian path to vehicular path. So basically it's saying you're leaving a safe area, now you're entering into a dangerous area where vehicles are. It's not a wayfinding device, so we don't want to use a detectable warning surface to point them where they want to go. That we want to use the ramp to line up origin and destination. And MDOT, we have a qualified products list that people can go on and look at that we allow on our projects. Okay. So for example, you want to, like I keep saying, you want to use the ramp orientation for wayfinding. So on that first slide, you can see that they use the ramp and they're kind of using a detectable warning surface to say this is the direction you should be going. But it would be better to change the alignment of the ramp to point them where they need to go instead of trying to use the detectable warning surface as a wayfinding device. That freeze up here. There we go.
If all else fails, look at the laptop because it's just a little bit of a lag.
Yeah, I've seen that. I've noticed that. Yep. Okay, so the technical warning surface has to be the full width of the ramp, 2 feet wide at a minimum. And you want full continuous coverage where the curb has been removed. So, okay, so where do you put the grade breaks, right? We have a lot of different grade breaks on these things. You always want them 90 degrees to the ramp path of travel. So wherever there's a grade break, because you'll have them sometimes at the top, you'll have them at the bottom, you have them at the landing, sometimes you have 2 or 3 or more grade breaks. But you always want to have the grade break 90 degrees to the ramp path of travel. You don't want them skewed. Skewed grade breaks are a problem. They can cause the chair to tip, wobble, and all kinds of things. Sometimes they'll get a caster stuck at the bottom because they're on a skew, or they can actually tip over if the skew is bad enough. So we always want those grade breaks 90 degrees to the ramp path of travel. So how do you achieve a 90-degree to the ramp path on a radius? Well, you move the grade break back. You just move it back some to get that 90 degrees. And that little funky triangle that you get in the radius there, you just want to maintain that as a 2 to 5% running slope. So they'll be able to go over the grade break straight ahead, and then they'll have a nice smooth flush transition out into the roadway. So if you have to move the grade break back 5 feet or less, then the detectable warning service can go behind the grade break. If the grade break is greater than 5 feet, so the grade break goes way back because it's on a radius, then you want to bring the detectable warning surface to the back of curb. And you notice that the grade break's not moving, just the detectable warning surfaces. So you always want to maintain that 90-degree ramp path of travel so they can get over it easily. And so you want to move the detectable warning surface. So if it's less than 5 feet, leave the detectable warning surface behind the grade break. More than 5 feet, bring it up to the back of curb. And you can also truncate these things. They don't necessarily have to go around the radius, they could be truncated. But if you truncate it, you can have 2 inches at the ends of the radius, and you still want to maintain full continuous coverage across the entire opening of where the curb has been removed. All right. All right, detectable warning surfaces at medians and railroad crossings. Well, if the median is less than 6 feet, there should be plenty of time in the crossing phase to go from one side of the road to the other side of the road. If the median is wider than 6 feet, it needs to have detectable warning surfaces on it. It could mean that they don't have enough time to get all the way across from both ends of the crossing, that they may have to stop in the median. So you want to have detectable warning surfaces in it. It gives them a place to stop and wait for the next signal phase, and then they'll be able to continue their cross. But if it's less than 6 feet, no detectable warning should be required in the median. They should be able to make that crossing. Railroads, they have to be 6 foot minimum from the nearest rail and 15 foot maximum from the rail. So I don't know. I was down in Chelsea, and I was standing 6 feet away from the closest rail, and they had a Amtrak go by at like 80 miles an hour. I didn't feel too comfortable standing 6 feet from it. So I don't know. You can go 6 foot is the minimum, but that doesn't necessarily mean you couldn't do 8 or 10. But you definitely don't want to go more than 15. But you may want to visit the site, see what kind of trains are going by there. If they're going by nice and slow, maybe 6 feet's fine. If they're going by 80, 90 miles an hour, you may want to bring them back just a touch to make them feel a little safer. So, staggered coverage. I've seen these around once in a while. We don't want to do staggered coverage because it allows for overstepping. You want to make sure it's a minimum 2 feet wide with full continuous coverage. The staggering will allow them to overstep it and they could miss it altogether and just walk right out into the street. And, you know, we want to make sure that they hit those detectable warning services and know that they're getting ready to go into a dangerous area. Okay, so location. What do you guys think about this one? Is it in the right spot? Should it be moved? Good to go?
Far back from there. Far. It's too far.
Too far, okay. That's too far back. So basically, the grade break is greater than 5 feet back from the back of curb there. So the detectable warning surface should be moved up to the back of curb. And then you want full continuous coverage and 2 feet wide minimum. Okay, contrast, light on dark, dark on light, right? You want a good contrast between the detectable warning surface and the pavement or the bricks or whatever we got going on there. Because low vision at a distance, you can see like gray on gray, it just washes right out. Can't even see it. And even the black on gray, sometimes when it's across the street with someone with low vision, they'll have a hard time seeing that. So you want a good contrast between the detectable warning surface and the pavement or the curb ramp. So yeah, so low vision at distance, you can see the gray on gray just washes out and the black on gray is a little harder to see. But the yellow and the red seem to work pretty good. But you wouldn't want to use red on red brick, right? So sometimes municipalities, they like the brick, so that looks good, but they don't want like a yellow one there, right? They're like, oh, the yellow is too bright, it doesn't match our decor or whatever. So it may be something, you know, like a gray one. It's a little better. It's not so over the top, but it's a better contrast. It's, you know, not the best. Obviously, yellow would probably be better in this situation, but you know, this would be a good negotiating point, right? So you just want good contrast for them to be able to see it. Rolled curbs and flares. So you want to use rolled curbs adjacent to non-walkable surfaces, permanent objects, things like this, where you know you don't expect anyone to be walking there. They shouldn't be walking there. It's not a prepared surface, or there's too many obstructions and things like that. You wouldn't want to use it adjacent to walkable surfaces, right? You know, because people are walking, all of a sudden it just drops off, or they're walking and there's all of a sudden a lip, they kick it, fall, trip and fall over. You know, everyone's playing with their phones and watching cars go by and things. So, you know, you wouldn't want to get someone injured by one of these things. So next to walkable surfaces, you want to use flares. So they have a nice transition between the ramp and the sidewalk, and they can just walk right up the ramp and the flare and right onto the sidewalk and just keep walking along. We can also do hybrid ones where you have rolled curb next to non-walkable surface areas, and we have flares for, you know, that would connect to walkable surfaces. And in this situation here, we can even reduce the curb height around the radius a little bit to achieve the flare slopes. So you don't want to have it too steep, so you can lower the curb height a little bit to meet the maximum slope of the flares. Okay. The different types of ramps. Okay, directional ramps. These are the preferred method of ramps. These you can, you know, they're independent of each other. You can use them to line up origin and destination like we've talked about. They come off the sidewalk, you know, the ramp is pointing them right where they need to go, you know, in both directions. That's the preferred optimal method of wayfinding. So if we can fit these in, you know, try by all means, the best you can to get these to work. You know, but we all know sometimes that doesn't happen, you know, just right away constraints, obstructions, you know, scope of work, things like this, we just can't fit those in. So we have blended transitions when directional ramps don't fit. So with a depressed corner, when the directional ramps can't fit, you can put in, you know, like I said, a depressed corner. You just want to lower that whole corner down, make that whole area 2% maximum, and basically like all the directions to try to make that your landing down at the bottom of it. And then you want to ramp it back up to the sidewalks. But if you have to do a depressed corner, you want to make sure you have full continuous coverage of the technical warning surface all the way around the radius wherever the curb has been removed. So that gets them off the road, they can turn, and they can go either way they want. So here's a parallel ramp. So basically, they just get off the road nice and flush. The landing's at the bottom, 2% in both directions. They just make their turn and go on the ramp to tie back into the sidewalk. You may or may not need landings at the top. That's the question marks forward. Depends on the 15-foot rule and the amount of rise, you know, the 30 inches of rise and things like that. So it depends on your situation and what it's like out in the field. You may or may not need other landings at the top of those ramps. Okay. Here's a combination ramp, a type C. Basically, you have a ramp that comes off the road. You go up the ramp to the landing like a perpendicular ramp. And then you have your landing at the top, you make your turn, and then you go back up your other ramps on to match up with your existing sidewalk. And again, at the top, the question marks are there, you know, because you may or may not need another landing at the top. So you just ramp up and do the turn and then go. It's a combination between a parallel and perpendicular ramp. All right. Well, that's not right. What happened here?
Is it not showing on here?
No,
I wonder, but it's that one. Oh, that one just changed. It was on there a second ago.
Yeah, no, it's, I think the Wi-Fi connection in here is stable. So,
Oh, yeah, we have that problem too sometimes.
yeah. Then it just kicks him right out.
We're at the diagonal ramp. Then
This one, right?
yeah, yeah. Yeah, perfect. Okay. Diagonal ramps are allowed in alterations, are not for new construction. So. Like I said, if you're building a brand new roadway, you know, through cornfield or the forest or something. These are not compliant. You can't put these in. They won't, you're not allowed to put these in. You're supposed to put in directional ones if you can. Because basically they allow for 3 points of entry, whereas the other one,
Is it not?
I don't know, it's not doing so.
Want to go back?
All right. Well, hopefully that works. All right. So this has got 3 points entry on a diagonal ramp, where the other one would have 2 points of entry. And if you do have them that are existing in an alteration and you already have a diagonal ramp, if you can, by all means, try to take them out and put in directional ones or something else, because you know they kind of point kitty corner, you know, they kind of go through the middle of the intersection. That's where they point. And again, we want to try to line up the ramp from origin to destination. So you want to, if possible, take them out and put in directional ones, so you point them in the right direction. However, if you have to leave them in and you upgrade them as a diagonal ramp, you at least have to have a clear space within the crosswalk for them to get out from the ramp into the road or into the crosswalk make their turn in this clear space. And then continue across the road. So you have to consider that. You just want to make sure they have a clear space within the crosswalk for them to make a turn. But if we can eliminate these, by all means, try to do so. Okay, the curb ramp opening, the counter slope. Remember, that's a 5% maximum counter slope. We want to design for something less than 5, because remember, their casters can get stuck at the bottom and things. So what you got to think about though is the gutter pan of these things, right? The gutter pan is about like 8%, and now you're flattening it out to 5% or less than 5%. So what you have to do is when you have to take out extra curb and gutter on both sides of the curb ramp, transition the gutter pan, up to something less than 5% across the curb ramp opening, and then you can transition to something steeper on the other side. So that goes hand in hand with how important it is to get a good survey, to visit the site when it's raining. Because now, you got a nice steep gutter pan, now you're flattening it out, you're flattening everything out, so now where's the water gonna go? So go out there when it's raining, check it out, because changing the gutter pan line, all of a sudden the water's gonna go there and stop. So it can't go around the radius anymore for some reason, because you flattened it out. Or maybe it still will, maybe there's enough slope that'll make it happen. But you got to keep that in mind that, yeah, it's 5% or less in the curb ramp opening, but to achieve that, you're gonna have to take more curb and gutter to make that compliant. So you get a nice smooth flush transition between the curb ramp and the road. So makes it nice, easy for them to get out, no bumps. You don't want that one down here is not flush. You don't want them stuck on it or have a hard time getting over that. You want a nice smooth flush transition between the curb ramp and the road. And that's achieved by running that, having that counter slope 5% or less. Back at curb lift, remember we used to see these all over the place. Everyone used to put these things in. They work for the water and the flow and things like that, but it wasn't good for people with wheelchairs. So if you see something like this, that it's not compliant, we need to get these out of there and put in that counter slope of 5% or less, get a nice smooth transition across there. So they don't have these humps to deal with. There are vertical surface discontinuities. So, pavement moves around, all these bricks move around, we get it. So they allow a 1/4 inch or less for no treatment would be required. So if it's 1/4 inch or less vertical surface discontinuity, they can just carry on. If it's a 1/4 inch to a 1/2 inch, it should be beveled at a bare minimum. And a 1/2 inch or greater, it's ramped. So if you have vertical surface discontinuities, you want to take a look at how much difference there is, and then determine if you need to bevel it or ramp it. Okay, chasing grades, right? We probably all run into this. If we go back and now we're compliant, then we got to go back and we're working. It's like these never-ending story, right? So they came up with the 15-foot rule. And essentially, the maximum ramp slope is 8.33%. However, it should not require the ramp length to exceed 15 feet. So if it turns out you're chasing grades, you can stop at 15 feet. So that means that if in 15 feet, it could be 9% or 10% or something. So it could be steeper than the 8%, 8.3% in the 15 feet. So you can exceed 8.3% if it would take you more than 15 feet to match existing sidewalk. However, unlike the construction tolerances I mentioned earlier, this is not an absolute maximum. You can consider reasonable increases in distances to achieve a compliant running slope. So for example, at 15 feet, let's say it's 8.5%. You know, it's higher than the 8.3% in 15 feet. Yeah, sure, you can stop there. But you should consider, what if you took another flag, you know, maybe if you went 20 feet or 2 flags, 25 feet, and it brought that 8.5 to like 7.9 or 8.2% or something compliant, something less than the 8.3%. You guys should consider that. Think about that, you know, because especially in the area, because Dan Troy used to talk about how they did this, and they only had to take a couple more flags to make it compliant, but you know, they left it at 15 and the guy was taking his wheelchair in the street. So, you know, consider taking extra flags if it would make a compliant running slope. Sometimes it doesn't, you know, sometimes, you go out 30, 40 feet and it's still going to be 9-10%. Well, then you have to balance all the requirements and the accessibility, things like that, and determine where's enough. But with the 15-foot rule, you can consider reasonable increases in distances to try to make it a compliant running slope. Okay, so the 15-foot, it doesn't count landings and transitions. So you want to start at the grade break and then just count your ramp runs. So you'd have your first ramp, and then you'd have a landing, and then you'd have your ramp. And then you'd have a transition slab between the last ramp and the existing sidewalk. So landings and transitions are not counted within the 15 feet. So keep that in mind as well. Sidewalk grades, it's a 5% maximum sidewalk grade. 5%, the sidewalk can exceed the 5% to match the existing road profile grade, right? So basically that means if the road is at 6 or 7%, right? 6%, let's just say 6%, the sidewalk grade can match the road profile grade. So it can be, your sidewalk grade can be 6% as well. Now, if you exceed the 5% and the road profile grade, then the ramp rules are going to apply. So let's say your road is at 6%, your sidewalk is at 7%. Well, now you've exceeded the 5% and you've exceeded the road profile grade. So now you're going to apply all the ramp rules, or the maximum is 8.33%, 30-inch maximum rise with 5x5 landings. Okay. All right, there it goes. Landings. Again, remember, we mentioned this slide earlier. The landings are 5x5, right? We want to build them 5x5. If they don't fit, you can make them 4x4 if they're not practicable. If they're 2% cross slope in both directions, again, that's the maximum. So design for something less. They're required at perpendicular ramps, so you have to put those in on perpendicular ramps. If there's an intersecting sidewalk here, you want to make sure that you have a turning space there. But they're not required at blended transitions where the ramps are less than 5%. So what do you guys think? Do you think you need a landing there? It's a trick question. It depends. It's a perpendicular ramp, so yeah, you need it at the top of the perpendicular ramps. However, it's not required at blended transitions. So if this ramp is less than 5%, so let's say it comes off the road at 4% or 3.5% or whatever, you're not going to be required to have a landing at the top of it. It's just a continuation kind of the sidewalk if it's less than 5%, but you still need to have the detectable warning surface in place. All right. So what do you guys think on this? What do you think you need landings on this?
Yeah.
Yeah, okay. Well, the sidewalk, you got a 6% running slope with the sidewalks, you got a 6.5% running slope on the other sidewalk. So we're above the 5%, right? So a blended transition is not gonna apply here. So you have, it is a perpendicular ramp. So you have to have a landing at the top of the perpendicular ramp. Okay, so what about the question marks? Do you think you need them at the top of the at the top of the ramps there? Maybe, I don't know. I didn't bring my calculator with me, but it's a 30 inches of rise for. Oh, and a 15-foot rule makes a landing requirement unlikely. It would take a 17% slope to gain 30 inches in that 15 feet. So at the top of those, it would probably not be required. Matching cross slopes to road grades. New roadway, okay, again, was real quick. Yeah, full compliance is gonna be required. So if you build a brand new road, a 2% maximum at stop signs, 5% at signalized or uncontrolled intersections. And match the road profile grade at mid-block crossings. Existing roads, you want to transition to meet the existing road grade. Adjust crosswalk to the extent practical to reduce cross slope. If new construction standards are impractical. So basically. You're allowed to match the road profile grade. And you can exceed, you know, your 2% cross slope and some of these things. But if possible, you want to apply the new roadway construction. So if you're doing a mill and fill or road construction or something, you can try to get to 2% at stop signs, you know, try to get to 5% cross slope at signalized or uncontrolled intersections. And then the match road profile grade at mid-block crossings, that's going to happen anyways.
Bill? We've got a question on the QA portion of the Zoom. What about chasing cross slope for 15 feet? Do you include the landings and transitions then?
No,
No.
no. No, you wouldn't include, no, you don't, I don't know where I'm.
You don't include the landings and
You don't think of it as a one piece or one part that you're trying to do within the 15 feet. You just want to try to have a compliant running slope, a compliant cross slope, compliant landings. And everything is compliant within that 15 feet. And then the transition slab is
to get you back.
to get you back to match whatever's there, whether it's compliant or non-compliant.
Okay. All right. Thanks.
Okay. So for example, you start at the top, right? You got a landing that's 2% cross slopes in both directions. And you have an existing crossroad or existing road that's something greater than 2%. So you have to transition the full length of the ramp. So you'll start at the top at a 2% cross slope, but at the bottom, it's something greater than 2%. So you want to have a nice smooth transition over the entire length of the ramp. You don't want to carry that 2% down for like half the ramp and then flip it to something more than 2% or something like that, or 2/3 or anything like that. You want to have a nice smooth transition from the top to the bottom. So it doesn't have any like, you know, possibility for them to tip over or you know, go over a break or anything like that. So you want to take advantage of do a nice smooth transition between the landing and the road. Path of travel. Buildings, pathing to accessible features. For buildings, they said that in the ADAG, it needs to be, everything needs a path to accessible features. But in the ProAg, it's public rights of way, it's just too massive, it's too big. So we just can't have paths leading to every single accessible feature within the right of way. So, okay, what do you guys think of this one? Oh, I got questions on these slides too, okay. All right, first off, do you need a ramp? What about the sidewalk? I gotta fix the sidewalk. All right, a detectable warning pad, and pad, yes. Okay, at a bare minimum, we got, so this is the difference between MDOT jobs and local municipality jobs. MDOT, we go through, we'll do a mill and fill on our road and we'll take care of the. You know, the curb ramps and the openings and things like this, so. Unless there's some special agreement, we won't address the sidewalk. But if this was like a Delta Township job or a, you know, a city job or something, I mean. Those guys own the sidewalk, right? So when they go through it. They'll want to fix the ramp and, you know, they should be considering on replacing the sidewalk or fixing it up or whatever. But for an MDOT job, we just go through and put a detectable warning and pad and we wouldn't address the sidewalk. All right, so what if there is no sidewalk? What if, remember we talked about ramps to nowhere earlier? You know, there's no, well, I think I got a question. There's no ped signal, right? There's no evidence of travel. So no treatment should be required. So if you had a ped signal, right, they put in a ped signal, you'd at least have to have a refuge. If ped signals are present, you have to have a refuge. You have to have a place for them to get off the road, sit there somewhere safe, wait for the signal to do its thing, and then turn around and go back. Okay. A marked shoulder could also be used as an alternate refuge. So if there's ped signals there and you have a marked shoulder, they could sit on that marked shoulder out of traffic, wait for the signal to do its phase, and then they'll be able to turn around and go back. Now, if the ped signal is a ped activated ped signal, or it's actually got a push button to it, you have to make that push button accessible. So you'd have to have them be able to get off the road, have a pad to sit on, be able to get to that button and push it. So it would activate the signal so they could turn around and go back. And the refuge should be a level all weather surface. So they can just get out of the road, you know, hit that button, turn around, and at least go back in the direction they came from. Ramps, detectable warnings and driveways. All right, what do you guys think here? You need a detectable warning at all these driveways? Absolutely not. Basically, detectable warnings that signalize or stop yield controlled driveways only. So it has to be a regulatory sign, you know, official stop sign, official yield sign, traffic signals, things like this. Then you would have to have detectable warning services. Yeah, this is too much. It can't be like a mom and pop sign stuck in a concrete bucket, you know, with please stop, you know, things like that. It has to be an official regulatory sign. I get a lot of questions about like all retail areas like Myers and Walmarts and things like that. Basically, again, if it's stop yield control, has signalized, you has to have detectable warning services. The good rule of thumb, Steve said it the other day, if it
If
it
it
acts like a road,
looks like a road,
it looks like a quacks like a duck.
yep,
If it looks like a road, acts like
you
a
gotta treat it
road,
like that.
you should treat it like that, right? Exactly right. So. All right, so that's when you would put in the detectable warning services.
Oh, we've got another question.
Sure.
Can a pedestrian traffic study eliminate some ADA requirements? When there are no pedestrians in a rural area?
Well, we don't ever want to remove accessible features. So it's never a good idea to remove any ADA requirements, even though, I mean, because some rural areas, there are only going to be a few people. So we still have to have ADA requirements.
It still has to be accessible to everyone.
Yes.
Okay.
Yeah. The only thing I could add to that is a safety thing. is if it is just flat out unsafe for someone to cross, then you can, I don't want to say eliminate that crossing, but it should be,
Force them to go somewhere else? or-
yeah, it should be, you should consider sending them in a safe area or a safer crossing to get them to the same destination. So you can do it, but you have to be real careful with how you do it.
One more question. What is the clearance required for signposts in the sidewalk?
Oh, I got a slide come up on that. It's called protrusion limits and it's 4 inches on the side and 80 inches high.
Okay.
But I got a slide coming up on that. Did you guys have any questions on here? Or are you guys just posting them online over here? All right, so anyways, cross slopes at driveways. You want to maintain that 2% cross slope across driveway openings. So that they can just continue on the pedestrian access route without having a side slope. Sometimes those get tricky. You just gotta think outside the box sometimes, work with the property owners to try to get that 2%. Sidewalk zones, we have 3 different zones. We have the frontage zone, the pedestrian zone, and a furniture zone. The pedestrian zone is the only zone that we're concerned about maintaining the 2% cross slope. Okay, so this goes hand in hand with the question about the clear width for a sidewalk. Again, we try to build all our sidewalks here in Michigan 5x5, right? 4x4 works, you can't make them less than 4 feet, but you want to try to build them 5 foot wide or better. If you build them at 4 feet, you have to have a 5x5 passing space every 200 feet. And you're allowed protrusion limits for signs and low hanging trees and so on and so forth. But it'd be 4 inches maximum on the side and no less than 80 inches. So. But we want to try to build these things at least 5 feet if possible. Okay. Again, the pedestrian access zone, the pedestrian zone is the 2% cross slope. Anything outside of that could be something steeper than 2%. So, for example, here we got 2%, then we got something steeper than 2% down to the road front, which it looks like that might be 2% down there. But you have to, when you see something like this, you have to consider what's going on along the road front there. What if there's parking meters or park benches or mailboxes or, whatever is down there. You want to be able to make sure that area is accessible from the pedestrian zone to the frontage zone or the side or the road front. So you could have something steeper between, or you could have, maybe that's just like a brick pavers or something, or a little rock wall with steps down it. But then at the end, you'd have to put like, turnbacks or something so they can get up and down between the 2 areas. You just want to make sure it's accessible, that's all. Physical constraints, where physical constraints make it impractical to fully comply, compliance is required to the extent practicable. And then it must be documented. So basically what that's saying is if you can't make it compliant, 100% compliant, you make it the best you can. Do the best thing you can to make it as accessible as possible. Even though it's not compliant, you built it to the extent practical that you could to try to make it accessible. And then since it's not fully compliant, you want to document it. We at MDOT, we have a form. I'll show you the form coming up. But you guys may want your own forms. You may want to create your own forms. Feel free to steal our form. It doesn't matter to me. But you should at least document it, keep it with the project files. Because you never know, some attorney may come knocking on your door saying, what's going on here? And then you'll have documentation to back it up, how you came up to that decision on how you made it or built it. All right, so constraint arguments are only valid for alterations, not for new construction. Remember, the new construction's brand new, you have a blank page to play with, you need to have full compliance. So You can't build something brand new and say, well, I built in constraints, you know, it's like, you should have thought about it. So constraint arguments are good for alterations, but they're not for new construction. Undue cost burden is a difficult justification. You know, well, this is just gonna cost too much. Well, if you get drug into court, they say, well, how much, they look at the total cost of redoing the ramps to your total budget, and it turns out to be a very small number. So most judges aren't gonna fall for that. So just saying it's gonna cost too much, you're probably gonna end up having some judge telling you how to spend your money. So the undue cost burden is a very difficult justification as to not being able to make something fully compliant. But scope of work might be a consideration. You know, what if you can't get right away? You know, you're not getting right away anywhere else on the job. And you just you don't have, you know, any right of way for it. What about utilities? You know, if you're not doing any underground utilities, you're not adjusting covers and all these things. I mean, you can adjust some covers, but if you're not doing underground utilities and stuff, or moving, you know, poles around and things, that might be a justification. Terrain, right? We talked about like the 15-foot rule chasing grades, where, you know, if we're up in Marquette or something, you got a huge grade going up, you just can't get the compliant running slope and things like that. So, you know, terrain could be a consideration. And then regardless, document it. So, like I say, if it's not compliant, you for sure want to document it and keep it with your project files. If it's your run-of-the-mill curb ramp that it's like almost cookie cutter, just bang right through, yeah, okay, you don't have to document those. You get something in an urban area where you have to manipulate a bunch of different things, and it took a lot of time to figure out to make a compliant curb ramp to fit in there in a radius. Even though it's compliant, you may want to document it anyways. I mean, it's good for you, it's good for the next guy that designs it, and be like, how does this guy come up with this? You know, he'll be able to see your plans, he'll be able to see your notes. You might want to document, you know, how you came up with the idea of, you know, the layout to make that compliant. So even though it's compliant, it was a difficult one, it may be worth documenting anyways. We use it's can't see, oh, you can, it's the 037 form there at the top. Oh, there it goes. But you can go to MDOT, you know, forms, whether you look up the 370 form. And this is what we use in our design layout. If we cannot design something, the designer cannot lay it out on the plans compliant. This is what the designer used to fill out. Now, if the designer makes designs it and it's fully compliant, and for some reason they get out in the field and they look at the site assessment and they're like, oh, well, there's obstructions here, there's obstructions there, you know, we can't move this, we can't move that, we don't have right of way, blah, blah, blah. Construction has a 1105 form that we use, but that's on the construction side of things. Since this is a design training, I don't put that in there, but we have a form for our designs or our construction staff as well for non-compliant curb ramps. Accessibility first. When full compliance is not practicable, think in terms of maximum accessibility first, then balance requirements, right? Like I said, don't make it less accessible. You want to try to, you know, build it to the extent practicable, so it's everything, you know, you don't want to just apply the standards as a cookie cutter, because it'll make things less accessible sometimes. So, yeah, don't make things less accessible. Change down there, but not up here.
Yeah,
Believe it'll
Or is just thinking.
it's either slow or lost
There's a
connection.
I only have a couple
it's
more slides.
unstable, it says, the internet.
That's,
I just got a message. There we
Yeah.
go.
well, yeah, don't make things worse.
Oh, no,
But
I shared,
you want to share it?
shared it,
That's fine. There you go.
share.
It's coming back.
There we go. Well, don't make things worse. So, and then I think I only have one more slide anyways. I just want to do a quick summary of the presentation. So it just kind of hits some key points. But basically, at the beginning of the presentation, we talked about there's no construction tolerances on the maximum, there's minimums, you know, that's the cross slopes, that's the running slope, you know, the ramp slope, 8.3%. You know, the 5% counter slope, right? Detectable warning surfaces are not for wayfinding, right? We want to use the ramp to line up origin to destination. The grade breaks, all the grade breaks, we want to try to get those 90 degrees to the ramp path of travel. And then, of course, I want to nail down the directional ramps are ideal. If we can get those in, those are the ideal way of optimal wayfinding. So if directional ramps can fit, let's try to get those in there. The 15-foot rule for chasing grades, remember, that's not an absolute maximum like the construction tolerances. That you can consider reasonable increases in distances to try to achieve a compliant running slope. And then think about accessibility first. If all this stuff comes together and everything, you just can't make it compliant. Think of just accessibility first, try to get them to where they need to be, you know, even though it may be a steeper slope, things like that, but just think of accessibility first and don't make things worse. And then, of course, documentation. You know, we talked about that. If it's not compliant, you want to document it. If you have something complicated or if it's worth documenting, you should consider doing that as well. Keep everything with the project files. But I think that was it for me. If you guys had questions, I'm open for questions.
Yeah, on that counter slope, 5% counter slope. Is that the delta between two slopes? Let's say you've got 8% coming this way. Are you saying you can have a 13%, you know, 8 down and then 5 up? Or I guess I lost you on what the 5% is relative to.
Yeah, it's not a delta, it's not a difference between the two. You just want to have that 5%. Well, I guess it is a between, but it's not, you don't want to. I guess it's hard to explain it, but you don't want to more than 5% counter slope between the ramp and the gutter pan. So when they come together, it has to be less than the 5%.
So that's the difference between the
On
two.
the ramp, right?
Yeah,
If you're coming down a ramp at 8% and then you have the grade break, from the grade break to the back of curve, you're trying to keep it at roughly 0 or maybe a slight slope to it, and then a max of 5 in the gutter pan.
yeah,
Is that what you're saying?
yeah. It's well, that area is at between 2 and 5% between.
1 and 4 work.
Oh,
Did that answer your question, Adam? I think so.
okay.
There we go. We don't have sun in our eyes.
So,
Because that's usually what happens. You're coming down the ramp,
yeah,
hit the grade break. And then it roughly flattens out, you know, you want to have some slope in that area, so you don't have a puddle at the bottom of the ramp all the time.
yeah, you get that little
So
triangle
you
or
want
something.
to keep it going, sloping towards that gutter area, right?
Mhm.
And then it's a max of 5 in the gutter pan, or the difference between what Adam is saying, if I come down at 1 from the grade break to the flow line, if I come at 1%, is it a maximum of 4? That's what you're saying. Or is it just a straight max of 5 in that gutter pan area?
It's a straight max of 5%
Okay.
gutter pan here.
All right,
So regardless of what the ramp is doing.
coming in, yeah.
Yeah,
Well, you're gonna have a grade break, so that it will break that slope, and then you're gonna be at,
right.
you know, 2% from max of 2% from there to the flow line.
Mhm.
So really the max difference is 7.
Right.
But he's also saying, take that gutter pan back slope that's creating your flow line and try to flatten that out a little bit in that area too, so you don't have that 2 to 5 break change in slope. That makes sense?
Okay.
Any others? Any others on the QA?
Nope. No, just one presentation.
Oh, yeah, we will definitely be posting these presentations online.
Yep.
You talked about the signposts. clearance for signposts and things in the sidewalk for that, 80 inches tall, which, thank you for that, I'm 77 inches tall. And then, 4 inches max protrusion over the 5 foot. If you have a 5 foot sidewalk, you could have a max of 4 inches.
Well, even
protrusion.
a 4 foot.
Or even on a 4 foot, okay.
Yeah, we try to build 5 foot, but you can build a 4 foot, but you can still have the 4 foot.
4 inch still applies to that, okay.
Yeah, Pro Ag allows the 4 foot, but we try to build 5.
Yep. And you don't need the passing spaces.
Right.
So, all right. Any other questions on the ADA portion? Okay, very good. Let's do a 15-minute break. Get up, stretch, get some coffee. We'll start back up at 9:30.
I'm gonna hang out over a minute. if
Yeah,
anyone
feel
wants
free to grab Bill and ask him any personal questions. Yeah, actually, those are the ones we were asking as we went along. So I'll verify to make sure that those were all covered as well.
I've got. I've got one here.
Make some changes.
Okay, are we back?
Yep, we are back. All right, so do you want to read the question and then I'll slide this over?
Yeah, that's fine. So can there be a grade break in the gutter slope high point in the middle of the depressed corner ramp, take D? I wouldn't recommend that because you know, it's gonna affect the water flow around the radius. It could create ponding and things. So I would not recommend a high point in the middle of a type D.
In the gutter slope, so they're talking about a high point kind of right here, so that water flows. Like
Yeah, but
that.
they're in a type D, so,
Do you remember where that is in the PowerPoint?
yeah. Well, I can do this. It's in the ramp type.
You see, it's coming here. Just look at this. You'll catch it eventually.
Right there.
Breast corner type D. Like, see if it catches up.
It might get there.
There we are.
Yeah, so it sounded like they're talking about. A high point. Yep, down here,
In the gutter,
yep,
right? Yeah.
so, yeah, that doesn't, yeah, I wouldn't recommend that because, you know, it's gonna interrupt the water flow line. You're gonna have a hump out in the road that people are gonna drive over, you know, I wouldn't recommend a high point in the middle of a depressed corner.
Okay.
What is the guidance to transition between cross slopes over 2% to the 2%, to the required 2%?
Yeah.
That was the slide I had earlier.
So we gotta go back up.
Let's see. Will I go back?
Keep going, no, keep going. Right there.
Yeah,
That's fine.
yeah, that's fine.
Okay.
Okay, so,
From greater than 2% to the required 2%.
yeah, so basically. I don't know if they can see this thing or not, but you want your 2% cross slope right there, right? Your last ramp run is gonna be a 2% cross slope, it's gonna be compliant. Your transition slab is gonna start at your 2% cross slope to match your ramp run, right, to be compliant. And then you want to transition over the full length of that transition slab to match the existing sidewalk. So let's say your existing sidewalk is at a 4% cross slope. So you'll start at 2% where to match your compliant ramp run. And then you would transition over the entire transition slab to the 4% cross slope to meet the existing sidewalk. Or whatever the existing sidewalk's doing. If it's sloping even the other way, you'd have to kind of warp it even the opposite direction or whatever.
Yep.
Whatever you need to do to make it
Happens over the full length of that transition.
yeah. Similarly to the that one slide I showed you where we had the landing at the top, where you have to meet the road grade at the bottom. You start at the 2% at the top and it's something greater than 2% at the bottom
To match the road.
to match the road, same idea.
So that's that one. Okay, obstacle.
If you have an obstacle at the location of the insert handhole, and it's not possible to install the full width of the tile, what are the requirements? Engineering judgment, yeah, the detectable warning surface, it needs to be 2 feet wide, and full continuous coverage across the opening. Sometimes there are utility access holes, manholes, handholes, whatever.
Can you cut around them?
You can cut around them, yeah, then it's no longer compliant.
We got gate valves, boxes, water valves.
Yeah. I don't see, so it's an engineering judgment thing. Sometimes you can move the detectable warning surface behind it. Sometimes you have to just cut it. If you don't have 2 foot wide minimum and full continuous coverage, I would definitely document it as non-compliant. Just to cover yourself. But yeah, there's all different scenarios out there. You're just gonna have to try to find the best solution to get the most coverage as possible. Unfortunately, that's the only thing, there's so many scenarios.
This one.
All right, you got a -1% and a -1.5% away from the high point in the middle of the corner. It's technically less than 2%. Yeah, I would say that should be okay, yeah.
Okay.
It's less than the 2%, so that should be okay.
All right.
Let's see, when referring to detectable warnings location. Before or after the grade break, when encountering a document for reference to MDOT standards. Okay, it's in R28J, it's on page 6.
Yeah, you wanted me to.
It's on page 6 of R28J.
Let's see.
Can we bring that up or no?
Now, we can probably bring that up. I just need to move a couple.
I've got
of
2 more
things.
questions too.
Oh, I didn't cancel anything, did I? I'll show this as soon as we
Yeah.
person 2 is using it. All right, michigan.gov/ wrong. That's too many computers. Oh. And
Well, I would have just Googled
Googled?
that R28J.
okay, that's easier.
I don't know, I brought it up, I think it'd bring it up really fast, because it's usually right at the top,
And R
R28J,
28
yeah,
standard plan, right?
yeah. Yeah, it's good. Well, yeah, okay.
Keyword.
Standard plans index,
Road appointments.
Rural plans.
yeah. Well, that's a-
28J. All right, let me go back and share my screen here. Yes, and we're going to share our current screen. This.
Oh, it's down at the bottom there. It should be on page 6. Yeah, right there at the top, right top, right, yeah, there we go.
That's fine.
Yeah, so basically it says if it's greater than 5% or 5 feet. Then the detectable warning surface has to be located behind it. Yeah. Yep, at the back of curb. If it's less than 5 feet, it goes behind the grade break.
That's the answer to that question.
We've 2 more.
All right, I can close this, I think, right?
Yes.
Since we opened.
Okay. We go to Q&A here. All right, that one was answered. This one. Oh, that's
That's what we just did. You just said answered by it, yeah. No, that's fine. Go back. You said answered by.
oh, this one we did. Obstacle, we did all those. Okay. Done.
Yeah.
DWS at railroad.
Detectable warning service at railroads, if there's a paved surface adjacent to the pedestrian pathway, does the detectable warning service need to extend across the entire paved surface? Pretty deep in the railroad.
Must be, like you said, a little maintenance paved area parallel to the railroad going off 30 feet to the right of your sidewalk.
Yeah, I don't, yeah, without actually, I don't know on that one. I would think not. because that, I wouldn't consider that part of the pedestrian access route. If that paved surface is adjacent to the railroad and it's part of the pedestrian access route, then it would require a detectable warning service, but it doesn't sound like to me that that's actually part of the pedestrian access route.
Yeah.
Sounds like more like a maintenance thing
Yeah.
to me. So I hope that answered that question.
These two are, I think, gonna be summarized in this one.
Oh, that was the same one.
Yeah, they put it all in the same
Oh, I see.
question. So here we go. Here's the full question.
Was, oh, can the grade break and the gutter slope high point in the middle of a depressed corner ramp? Did we just,
Yeah,
Oh.
they combined them into one. They had two separate questions and
Oh,
they were the same. So that now all in one question here.
okay,
So a high point,
but it's still in the gutter slope.
yes.
Oh, yeah,
It's-
so. Well, okay, so the other one I see, if it's in the gutter slope, I would say no, you shouldn't, I don't recommend putting a high point in the gutter slope.
But it's there probably to try to direct water away from the depressed corner.
I don't
You know
understand.
what I'm saying? So that the water flows back around the corner, the curves, you know, the radius to the spring points where the.
Oh, I
catch
see,
basins are.
oh, I see what they're saying,
Or the-
to direct the water flow. Yeah, I still. Yeah, I think that's all right. Yeah, okay, yeah, to direct water away, yeah, okay, that would probably be all right.
Yeah,
Yeah, you're just
They're
controlling the
saying that.
water.
it's probably in the travel pedestrian pathway, so it's. A crowned pedestrian pathway, 1% and 1.5%.
Yeah,
That's okay, right?
yeah, absolutely, yeah,
Still not greater than 2%.
yeah,
Okay,
I think that would be okay. Yeah,
All right.
I still think that's all right.
okay.
Anything else?
Any
Anybody?
other questions before we let Bill, to clarify, if a valve cover is centered on a detectable warning surface and a circle is cut out, is that non-compliant?
Correct, yes, it is.
It is not compliant. It needs to be documented, right?
Yep, and then document it, yep.
Okay,
Cause there's that one fluke chance that someone steps on that one spot and steps over it, and next thing you know, they didn't hit any detectable warning at all.
Yeah.
I mean. Chances of that, I don't know.
there's always a chance.
There's always a chance, but yes, that would be considered non-compliant, and you should document that.
Okay,
Does someone make a glove box cover that has the domes on
I
it?
think so. I've seen ones with bumps in the casting,
Yeah, and I.
truncated domes.
I've heard of some of those too, but a lot of times what'll happen is when they take out like the manholes or something, they get rotated so the domes aren't oriented correctly.
Yeah, the valve ones I've seen with full full bumps, but there is it's not true compliant because there's a ridge around it too, so because the spacing and full coverage requirements don't apply then.
Yeah.
But there is I think East Jordan does have a valve cover
Yeah, right.
that does have truncated dome type of pattern on it.
Would that still make it?
It's still non-compliant because again, it's not a full coverage of those truncated domes with
Right.
proper spacing and everything else and orientation and all that. Right, but the good news is when someone with limited vision learns that corner, then they know that. So it's the first few times, you know, they've memorized those routes when people that pedestrians that do have low vision, they can memorize that and figure it out.
Yeah.
So they just have to learn it the first time, hopefully not the hard way.
I don't know why it's not compliant.
Yeah,
Well, sometimes it's for wheelchair users too, because they try to straddle the domes. So they don't go bumping across it with, spinal problems and things like that. So
Yeah.
it's kind of a twofold thing.
yeah, the domes are there for the blind folks, but the wheelchair folks don't like the domes.
That's right.
So, but we gotta accommodate everybody. That's the whole point of this.
Right. Try to
And
accommodate.
I and our grandparents and our little kids and our strollers and everything. So,
All right.
cool. Thanks, Bill.
Yes, no problem.